publication and data initiatives are going, and some interesting things that are happening at the moment. Quick summary for those of you who don't know the Royal Society of Chemistry very well. A couple of months ago we celebrated our 175th anniversary, which was very nice. And as of last year, we've become the world's largest quality chemistry publisher. We're a professional body. We do lots of things outside publishing in terms of representing chemical sciences, training chemical science teachers, things like that. About me particularly, I'm the publisher of data and databases. One of my prime roles is to help define how we move towards greater data publication, particularly alongside our other publishing activities in journals and books. But also my role covers professionally the sorts of advice that we look at as a society, how this sort of what this cultural change towards greater data openness means for chemists in general. So this means I tend to get involved in some of the open data activities as well as more specific projects, data integration projects, standards development, things like that. So I'll cover lots of these things during the course of the brief talk. I'll cover these three things really, some general things about the data landscape in the chemical sciences, data publishing, and then some specifics on data projects and initiatives which may be of interest. The data landscape, clearly as we've heard, there's a very interested push down from funders and government agencies towards a greater openness of research data. Just the last couple of days there's been a big conference in the EU around promoting open science as to how we actually make that happen. So this has been a really important driver and will continue to be a real driver from research funders and institutions as to how we get more data out there. There are other drivers out there, corporate requirements, particularly like pharma companies for collecting data and be able to integrate their data better when they've already got big data sets that don't necessarily overlap. The funder expectations and mandates in the UK, Philip mentioned things like data management plans. At the moment, all UK EPSRC funded researchers have to preserve their data with their institutions. That mandate came in last year, and there's an extension of that mandate to making that data more publicly available. So this is something that's happening now, and actually how that what those mandates mean in terms of the type of data that you collect and store, that's really evolving as people understand what the requirements are and what they keep and what they don't need to. Some of the opportunities, people are doing pilots around better open science and making their data more available, but these tend to be fairly limited, fairly small-scale pilots. And there's people are doing standards development, and this is an important enabler for how change will happen. But way down the list is really research and practice. All this stuff is still some way separated from that cultural change of what people would actually need to do and what would be needed to make people share and publish their data more easily. So I'll cover some things particularly around data publication. First couple of things around this, or things which are, I guess, really around how people publish a moment. So how that data can be seen and around the article, published article itself. There's some initiatives around data checking, so data checking before publication, so sort of validating data before it gets published. There are different approaches that people have taken to this. On the left there's this Wiley of testing, there's a NMR spectra checker, so you can upload your compound and spectral peaks and it'll tell you whether you think it's the right compound or not. Nature have taken a different approach in for some of their journals, actually having a reporting checklist. So this is a bit of bureaucracy, but I think it's a very interesting way to start building up expectations about the types of data that you should be reporting in a publication. I think this is a really interesting first step towards these sort of community standards. We're looking at things like chemical validation, so the compounds that we publish, actually checking that these are chemically valid and are fully described. And organic letters are actually employing a data analyst to look at some of their experimental data that's coming in to provide us a manual sense check on that. So there are different approaches which different publishers are taking around how some of the data can be checked on the way into publications. In terms of post-publication, most of the things that people have been doing in chemistry have really concentrated around small molecules because they're easy to describe and there's an existing standard. This is an example from Wiley. So in an organic chemistry article, you can get a compound browser of the compounds described and more information about those. Elsevier do something similar for some of their journals. Nature Chemistry do something similar. We do something similar as well. Again, all based really around capturing the chemical compound information and showing that in a better way. I think we all realise as publishers we have to show some of the value of this additional data before we can start expecting authors to be providing this as a matter of course. So I think in all these cases the publishers are doing some pump priming, spending the time cleaning up this data and showing it in a different way to see if this is a useful and powerful way to show people that they could be publishing more of their data alongside their articles. A couple of the other initiatives which I'll mention here without really any examples. One is data as the published articles, so there are some data journals coming out. These are really not really touching chemistry at the moment. Elsevier have just launched one called Chemical Data Collections. Nature have got a scientific data journal. But at the moment doesn't seem to be much appetite for just publishing data sets within the chemistry area. But it'll be interesting to see as to whether things like data journals take off. The other great opportunity, which is going to be hard to achieve, is this data not associated with publications. So the wonderful ideas of publishing negative results, of data which is boring but still really valuable. This is all things that should theoretically be of great value to communities to know this stuff and for people to get credit for publishing it. But at the moment, it's all the people we've spoken to. There's people would need a lot of work to do this, and at the moment there's not really an appetite to publish this stuff. So things aren't associated with a publication. So in terms of the raw science of chemistry, in my view, as we're trying to build more of an expectation and build more value around this data, it's clear that people will actually value this data that's already published alongside the publications. So this is actually what we're going to concentrate on, get this build up the culture of data publication alongside traditional publishing. And then we can move to more of the interesting unpublished opportunities around data. And it's also clear that when we're doing this, actually, it's the communities that build up their own expectations around what's useful and needed. I think it's really clear that that's exactly what you're doing in in your cost action. To actually build this expectation around standards, around data. They don't need to be formal standards necessarily, but it will take that expectation within a community, within a journal community, or within a particular project to build up these sort of standards, which publishers can then help to enforce and request some of this data alongside the publications. And this is essentially how we think we're going to contribute to this. Getting data into the process by slipstreaming existing publishing, helping to support and to encourage and to highlight some of these community standards, and working with our boards and other groups like yourselves to encourage these, and also taking part in some collaborative projects to test some of these things out and to enable some of these things. So that's from the publishing point of view. In terms of some of the initiatives around chemical data, I'll cover all these three things briefly. Standards development, the IUPAC is the major standards body for physical and applied chemistry. It's generally slow moving, so it's not always the fastest way to get standards implemented. The Industry Trust, so the industry is an identifier for small molecules. We are a member of that, and we essentially fund the development of the standards which come out of IUPAC around small molecules. So that means we can move a bit faster and really extend things like small molecule handling at the moment into things like polymers, which we'll be doing shortly, and to look at how things like Markov structures and patterns could be handled, inorganics and organometallics, the main things on the list, and things like reactions, which may also be of interest to you in the combustion area. Allotrope are a fairly new kid on the block. This has really come out of the pharma industry, trying to work with the instrument manufacturers to build a set of standards to interchange some of the instrumentation data which they're getting off, so the pharma companies can link together some of their data sets better. So this is, I think they've pre-released some of their standards, but they seem to have made a lot of progress in terms of getting buy-in from instrument manufacturers to how to implement this, and buy-in from pharma to fund a lot of it. So there's some interesting developments there. There's a list of some existing chemical standards. SIF and crystallography is the great poster child for everything. It's been developed, it's been adopted by the community. There's a great community data repository for it, and the expectations there. Some of the other data standards are in different elements of development and different levels of implementation with things like instrumentation, but they tend to be very niche, built up in certain areas. There are huge gaps in terms of needed standards. The Pistoia Alliance are another sort of membership body built around mostly pharma. They have a mission around enabling data interoperability and standards development. They're doing things around particularly ontology data, chemical safety data at the moment. So again, they do some things that are particularly of interest to the pharma organisations. A lot of this stuff also help, building on this general publishing infrastructure, the plumbing, some of the things heavily linked with some things that Laura was referencing around the infrastructure and the practices that the data science are also building in. So actually things like identifiers for institutions, for data points, for individuals, these are all really crucial things for helping linking some of this stuff together. A lot of these standards come out through NISO as well, so they're doing some interesting stuff at the moment around alternative metrics standards, so things like getting credit for data. There's some interesting stuff there from NISO, and also things like privacy standards for information around publishing, and that might also come into be of interest at some points when you're looking about what data you can share and what data you can't. The domain repositories are the big ones are fairly few and far between. The Cambridge Structural Database for Crystallography is the crystallography gold standard, PDB for larger molecules, and things like ChemSpider and PubChem for depositing small molecules. These things are all very standards based. Once you move out of that, you're looking at generic repositories where you can put in any types of data. But things like smaller repositories and different repositories. So the things that Philip was referring to in your area are really interesting to hear about. So coming towards the end, I just took a couple of interesting cross-domain projects around data and chemical data. We've been involved in Open Facts, which has been, I guess, an open data and a linked data project. The project itself is just coming to the end, but it's being supported by an ongoing foundation. And this has really been around linking existing, this is really about use of data and interoperability. So it's been linking existing database resources in chemistry to those from diseases, targets, biology, and to do this built on use cases from pharma to build better drug discovery. So this is, our role in this has really been around the quality control of the chemistry, so getting validated rules, agreed standards of what compounds should look like, and pushing all these chemical resources through the same filter so that everything can be accurately and queried across these different data sources, but linking stuff so that biologists can query the chemistry in a meaningful manner. So, but that's been a kind of semantic web project and a data integration project, and but lots of interesting things around using existing standards for things like units, building on existing things, building RDF publishing guidelines, working on things like provenance guidelines with the W3C, as to pulling together lots of different standards to build a better whole. So this is a really interesting project that we were involved in. I also wanted to raise finally the Research Data Alliance. So this is a real cross-domain project. Data Site are part of this. And it's really been there to bring together infrastructure and funders and researchers to help catalyse research data and increase research data sharing. There are very good groups around, general ones around data publication and things like data repositories. So I would also recommend you sort of have a poke around in some of these working and interest groups to see if there are useful things there that might help you guys out. We've set up recently a chemistry research data interest group. I guess the RDA wants to be a way of sort of bringing together best practice without necessarily taking on all the burdens of, say, chemistry research data, of which there are plenty. So it's we formed this group really as an umbrella group to pull together some of the cross-domain knowledge about some existing resources in the chemistry area, the standards, the development, the projects, but then use it as a discussion area for people to ask questions, to highlight use cases, without necessarily having expectations that this group will target and solve all these problems which are out there. This may not turn out to be the right sort of umbrella to do it, but it's been a useful exercise for lots of us who are involved in chemical information and chemical information problems to get together and have some discussions about this. So at the moment, anyone can join this particular group. There are some resources which we've just started building up on the. There's a wiki and there's a resource page, and I've added the SMARTCATs project as well as an area of interest within it. But again, this is something we'll be working on and helping to build up. I think some of the RDAs about there are some interesting things which chemistry can bring in that we've learned, which can help the rest of some of the other issues around research data. But also some general things around research data best practice, which we can help and we can adopt and take out into the communities as well, our particular communities as well. So some of this is really my second to last slide. We know all the things around cultural change. Standards can help, formal and informal standards. Ways of data handling for the researcher to make things easier. Things like the greater adoption of lab notebooks are things that we we're all interested in seeing how we can facilitate that to help people move towards lab notebooks or lab notebooks that support different types of chemistry. The metadata capture around all this, again, probably needs things like lab notebooks to be capture this stuff at the time or before the experiments are actually done, to help capture this stuff alongside the data and to, I guess, pull it through the process. And then publication and credit. So DataCite can help with some of these things around the citation, but also this the cultural change that people will actually get credit for things where they publish their data. They can see how it's being reused in ways that they're comfortable with. I couldn't find a useful place to put it in the presentation, but Laura may not be aware, but there's also at least one publisher, Henry Rosetta at Imperial College in London, who's depositing INCI strings with his DataCite metadata. So actually, the DataCite search, you can pick out some actual chemistry information because he's included that in his DataCite metadata. So it's a nice sort of test case for how things are going to be evolving. These are some of the organisations involved, both in the RDA chemical group, so some of the people from the ACS, Chemical Information Division of the ACS, and the IRC's Chemical Information Group. And really, it's trying to pull together these sorts of things which are interesting and identifying what we can do together to either cross publishers or cross organisations to help build on specific cases to help make that, encourage people towards that cultural change for greater data sharing. So thank you very much for listening. I'm happy to take any questions, provided I might need them to be asked closer to the microphone so I can hear them. But otherwise, thank you very much for listening.